Hello, my name is Mark Hobart. Together with my colleague Kola here, we're going to present test video number 19, The Monkeys Would Win. It's really a video about 60 types of dubious data. The point being that when we formulate policies, especially policies dealing with catastrophes, it must be based upon sound data. If we use flawed data, we get surprised when the catastrophe actually happens. I have the references here, and there's some displayed in front. Failure to recognize dubious data can be catastrophic. Even simple facts and truths can result in disaster, and I begin with the launch of the Challenger space mission on January 28, 1986. There were two facts at play here in some theories. The O-rings used in the rocket had specifications to only use in temperatures above 11.7 degrees, while the Weather Service reported a temperature of 36 degrees. 7 lives were lost by those two incontrovertible facts. It wasn't dubious at all. The engineers warned it was too cold, but the controlling board decided to launch anyway because of the tight schedules and cost issues with delays. The board was made up of non-engineer, probably political appointees. The engineers used the metric system, while the board was practical people who used Fahrenheit. You do the math. Did the board just decide the engineers were being too cautious, or did they not realize at the time the dubious nature of their understanding of the data? Obviously, after a disaster, the decision makers will try to evade culpability. You try to sort it out by doing some searches on the internet and coming up with all the evasions, excuses, lies, and rationalizations. Sort through them to reach your own conclusion. We must understand how data is supposed to work and be used. If we don't, we will cause or at least contribute to a catastrophe. Recent elections have proven classic examples of catastrophically wrong polls predicting the election outcome. And I submit to you that the polls were wrong because of Einstein's hidden variable theory. Let's take a look. I personally don't respond. We'll start with a microanalysis. I personally don't respond to polls or surveys. They take up your time. You're stored in their database as a willing participant and will be targeted for more polls and surveys in the future. You're providing data, big data, to create a profile of you in their database. If they don't like your responses, you make it onto their enemies list. You're placed on mailing lists. Your email inbox is flooded with spam, and they solicit you for money. So I don't participate in surveys and polls. Now, let's take a look at, and there are a couple of headlines down there below. Here's one. Dewey defeats Truman, Chicago Daily Tribune, November 3rd, 1948, quoted in Wikipedia. And now here the Des Moines Register comes up with one. Harris now leads Trump. She pulls ahead 47 to 44%. This is just a couple days, November 3rd, a couple days before the election. And now there's a postmortem. How did the Iowa poll get it so wrong? And I have here a Des Moines Register article that says the pollsters will be reviewing data after Iowa poll makes big Trump win. So yeah, of course you're going to look at the data now. Polling is only a prediction. It's not factual. They use sound statistical theory. Media conducts a poll for informational purposes. The final election results are the facts. The final tally from Iowa Secretary of State says Trump got 56.7% of the vote, Harris 43.3%, margin of about 13.46. The Iowa poll was baffled. How could we be so far off? Well, the Einstein hidden variable theory. The magnitude of the miss, they predicted a 3% win with a 3.5% margin of error, implying a standard deviation of 0.875%. That means they were 95% certain that Harris would win by at least 1.2% and perhaps by 4.7%. That should cover 95% of the possible outcomes in reality. But the actual margin of Trump's win was 13.46%. That's off by 16.96%. You take what they thought what Trump actually won by what they thought Harris would win by, that's 19.4 standard deviations. How big is 19.4 standard deviations? It's way beyond 99.99999% of probable outcomes. A monkey hitting keys at random on a typewriter keyboard for an infinite amount of time will most surely type any given text. That's the infinite monkey theorem. So how unlikely is that Harris would win 3.5%? Give 1,000 monkeys typewriters and let them randomly strike keys. How long would it take for one of them to type the Gettysburg Address? Modify the keyboard to help the monkeys out. Eliminate the shift key, the letters J, X, and Z, which do not appear in the Gettysburg Address, the numbers, symbols, punctuation, and spaces. Then give 1,000 humans telephones and have them conduct polls until one of them replicates the results of the Iowa poll. Assuming the Gettysburg Address has 268 words and 1,142 letters, and the letters must be typed in the correct order, how long would it take the monkeys for one of them to accomplish this task? You think, wow, that's not going to happen. How long before a human could replicate a poll in which Harris would win by 3%? Well, that's not going to happen either. Would the monkeys beat the humans? It might be close, but I think the monkeys would win. What happened? The Iowa poll missed a key variable. Obviously, a large number of people did not participate in the poll. Overwhelmingly, they had to be Trump supporters or Trump voters. They could have declined to participate for any of the reasons I listed. That's the hidden variable. Consider how the left behaves. Cancel culture, bullying, ridicule, suppression, censorship, violent protests, intolerance of other viewpoints. How did the voters feel? Fear, chilling effects of free speech, duress, intimidation. They felt threatened. There's definitely coercion, except at the polls. So what was measured is the Des Moines Register stumbled upon a measurement of the degree of voter intimidation and suppression in Iowa, which was inversely manifested in the actual election when compared to the Iowa poll. The Iowa poll was a catastrophic embarrassment of the Des Moines Register. It led to litigation alleging that it was intentional because nobody could be that stupid. Assuming the Des Moines Register is found innocent of manipulation and the incompetence was colossal in interpreting dubious data and not seeing it. I'm reminded of Tom Cruise in A Few Good Men. Colossal stupidity, galactic stupidity. The margin of error. Statistical theory uses the margin of error to define standard deviations. 95% of are within 2 standard deviations of the mean result of a poll. 3 standard deviations covers 99.7%. The scientific method, polling, and much research uses statistical theory to explain the results, to explain the accuracy of the mean figure. How do you spot bad science? Well, I have the poster right over there to Cola's right. Spotting Bad Science, the poster. Indeed, I saw a lot of that when I was reading green literature many years ago, and I came up with the mnemonic device DUPED, standing for dubious data, universal definitions, probabilities that a remote do happen. C is in spurious correlations, the C is silent. Extrapolation and distributions are not always normal. Those are 6 basic fallacies you see in green literature on the right and on the left. And so, to keep track, I was starting to use my mnemonic device, DUPED. Now I'm going to come to 60 errors in handling data. They are defining the problem and issue, defining the universe, defining what is data, identifying all the variables, collecting all the data in the universe, design flaws of your study, poll, eliminate human fingerprints, analyzing data, mathematical and statistical errors, inexplicable outcomes requiring further study, the clever Hans experiment. Now, this appendix coming up will list the 60 errors under those 10 categories, plus references and further reading. Misleading the data by words and symbols is a mnemonic device included there. Spotting bad science is an essential concept for catastrophic thinking. Support my efforts to become essential. Like, subscribe, comment, and share. I'm giving you permission to use this. Pray for peace. I'll end every video that way. Pray for peace. And then we go to the appendix. There's the mnemonic devices, and there's the defining the problems and issues, conflicts of interest, like money-motivated research to find a new vaccine, defining the universe, cherry picking, only the best data is selected. My favorite was the survivorship bias, where they were studying airplanes that had bullet holes in them to put more armor there, and then somebody said, hey, it's where the bullet holes are not in those planes. That means they came back, but where the bullet holes hit those areas, that's where the armor is needed. What is data? Assuming it exists, that it's in its final form, it's not been duplicated. Identify all the variables. McNamara's fallacy is the most famous, where he was looking at quantitative data and not considering non-metric factors that would also be important, like public opinion. Collect all the data in the universe. That's the Iowa poll fallacy, where they ignored 16% of the voters who did not vote, and Einstein's hidden variable theory, amongst others. Design flaws. Were there adequate control groups and blind testing? They didn't do that for vaccine development. Those were flaws. Eliminate human fingerprints. This is my favorite one. The Census Bureau fallacy assumes some data was missed and then estimate the sum that was missed. So you do all this work to collect data, and then you just muck it up with a human guess. Analyzing the data. Misleading, using those fallacies, because you can sure twist and spin and suppress the truth by the ways you use words and symbols. Consider your source. If it's mass media, it's got a speculative language in it. That's not good data. Mathematical errors. The high point is a sample size is too small. Well, these 5 people said this. What does that prove? Nothing. Other flaws and fallacies. The clever Hans experiment, where the counting horse was picking up visual clues from his people who were studying him, and so he could count out whatever they asked. What is this 3? And he'd stomp his hoof 3 times. That's human fingerprints. Design flaws, identifying the variables, and faulty attribution of causation to intelligence. And then I have all the further reading. So I encourage you to look at all of those things to develop your own approach to dealing with dubious data. Thank you. Pray for peace.